Um, I want to find out. Good afternoon, everyone. Anyway, my name is Mr. Henry Kweku Amoah. I'll be a facilitator for sorry for internet technologies and web. And this is a very practical course. So I'm sure we are going to limit the presentation, and then we'll get deeper into the practical aspects, actually doing the stuff what we needed to do, and at least take you through some of the things that you need to understand and all of that. So I would urge you that you try as much as possible to be behind your laptop, your computer every time. So you limit the usage of phone. Okay, so you can have a phone by which you're using to take the lessons and all of that, but you should have an extra device, a laptop that is close to you so that you can be doing whatever it is that we will be doing going forward. So what it means is that sometimes I'll ask you to share your screen. Okay, so sometimes you'll be asked to share your screen. All right, so then you'll be able to do whatever it is that we are doing together. Okay, so that's what I'm saying. You have to find a way and limit. If it's phone that you are sleeping on the bed and you are in the car and all of those things, it is not conducive at all. So once you have signed up for this course, then you need to be behind your laptop, be behind your computer, and then so we can together make some progress. And looking at the course content and the things that we need to do, I would want to suggest that beyond the Sunday 1 to 3 p.m. that we will normally have a class, I don't know if it will be appropriate for you to for us to schedule additionally some 2 days in the course of the week. Um, say Wednesday, Thursday, maybe after 8 p.m. So we can speed up work and all of that. I don't know if you guys are in agreement or something. So class rep, is he here? So unmute yourselves, and then let's see how we can make progress, speed up things. Okay, for level 300, I think we need to do more. So if you can hear me, unmute yourself. Yes. So in the course of the week, can we do additional schedule? Can we, because 2 hours for a week is inadequate. That's how I feel because of the course content. So unmute yourself, and then let's see what you also agree on, so that we can. Yes, Adams. I see Adams here. So yeah, unmute. Do you agree? Do you agree to scheduling maybe 2 days in the course of the week in addition to the Sunday? I don't know your schedule of work. So you just have to know so that I'll plan, accordingly. Okay. Yeah.
So, how long is the class going to take?
Oh, like 1 hour, most 1 hour, 30 minutes. We are done. We should be done.
Now, from
Okay.
Wednesday, is it Wednesday or Thursday?
Yes, Wednesday and Thursday.
Wednesday and Thursday.
Yes,
So meaning we'll be meeting 3 times in a week.
absolutely. That is for your own good. I mean,
I understand, sir. So meaning it's 1 hour, 1 hour.
Yes, yes. In the like, say, if it's Thursday, if we schedule around 8 p.m., because I know most of you are working and some are, in the course of the day, you are busy elsewhere and all of that. So Wednesday, Thursday, maybe 8. It depends on the time we all agree. So if it's 8 to 9, we do 8 to 9. Thursday, we do 8 to 9. Then on Sunday, which is our main class schedule, then we can add that one to, the week. So at least we can have three days in a week. What do you think? 3 days in a week as compared to 2 hours, one day in a week. I think
It's a good idea.
yes. So I want to hear from you. So let's agree together. Those that have not unmuted, please mute. Let's talk.
So the first shot is in now, so I think let's move to the first shot to this one.
For me, I'm okay.
Okay, so sir.
Okay, Prince is saying he's okay. Adams is saying he's okay. Noble, can you hear me?
Yes, sir. Hello?
Okay, do you agree?
Yes, please.
Okay, Andrew, unmute and say something. Do you agree? I can't hear you. Do you agree?
Yeah, yes, sir.
Great. So that's about
Okay.
4 of you. Salom. Am I sure I have Salom here? All right, class captain Stephen, do you agree?
So, sir, please, I just joined. So, can you enlighten me what we're talking about?
Okay, this is what I was talking about. I was saying that for a whole week, all right, and then our class
Yeah.
is only 2 hours. It's a technical course. Is not those other courses. These are technical stuff that we need to do. You understand? So I was only proposing that in the course of the week, if we can add Thursday, Wednesday, Thursday, 1 hour each day, in addition to the Sunday that we have our main class, so that we can do more. I mean, that's to your advantage. So that's what I've just thrown to the class to see if we are all in agreement. Then, I mean, we can schedule that and then we make progress. I mean, because it's a technical course. All right. So
Yeah.
I don't know if you agree.
Yeah, I'm okay with it.
Very well. Winner, I see winner on the list. Who is winner? Okay, so my class is very, very, very interactive. Okay, it's supposed to be interactive. So there are certain times where you are online, having a class, and then you have students join, and then they are doing something else. They join all right, but they have muted and they are doing something else. They have kept the device somewhere else, and then they are doing their own thing. And that will not be accepted here. So if you are joining, you join better. If you are not, then I understand you didn't come to class. You're not part of the class for that session. Okay, so like I'm saying, it's interactive. So I will be calling out names. I will ask you to share your screen and all of that. Okay, so that is how the nature of the course is going to be like. Okay, so it's not going to be all talk, and go and watch videos and all of that. No. You do it for me to see. Okay, all right. So let me take you some levels back. Give me a second. Let me pick my pen. Let me grab this information from you. Okay. Yes, level 300. So it means that you may have done certain, you may have treated certain topics, you may have done certain things in year 1, year 2, and now you're in year 3. Okay, so that I don't repeat myself, and then we can build on what you already know. Those that are struggling, we will help them out. Okay, so I want to know what you have treated so far with regards to, web design, web development, anything that you have done. So let me keep the list here, and then I'll just model the lecture around what you know, and then we'll build on it. Okay. So let me ask, have you done anything on HTML?
Yes, please.
Have you done anything on CSS?
Yes.
Have you done anything on JavaScript?
Yes, but I don't know for the other people.
Very well. So they will speak for themselves. So I have one. I have one. Yeah, Prince, you spoke, eh?
Yeah, Steven.
Okay, Steven, that's fine. Okay. Yes. So Noble, on mute, on
Yes,
mute.
please.
Have you done anything on HTML?
Yes, please.
No, please.
I heard two voices.
Hello?
Yes, Noble. Okay, you have the floor. Have you done anything on HTML,
Yes, please.
CSS,
Yes.
JavaScript?
Yeah.
Okay, so you know what an IDE is?
Pardon?
Do you know what an IDE? IDE. Do you know what it is?
Yes, sir.
Very well. Okay. So have you done any projects? Have you done any projects with any of these technologies?
No, sir. But we did a project work that we did a project work before we completed.
Okay, okay. All right. So at least I am getting some feedback. All right. Desmond, I heard you mention no. So you've not treated HTML?
Not yet. Like we did a surface, but that one was self-taught.
Okay, okay, okay.
Yes.
So yes, that one self-taught. Okay, all right. And then have you done anything on CSS?
Same.
Okay, CSS same. Have you done anything on JavaScript?
Not yet. I started learning not long ago
Okay,
myself as well.
okay, very well. So so you are more of a self-study. Okay, that's fine. Do you have any knowledge of a framework?
Yes, please.
Okay, what are some of the frameworks that you know about?
I know about Next.js and React.
Okay, you know,
But currently, my current company uses Next, so they require me to learn about that.
Next.js. Is it Node?
Yes, please.
Node.js?
No, Next, N-U-X-T.
NUXC. Oh, next. Oh, okay, okay, okay. Oh, next. Okay, all right. Okay, so that's a fair idea. Okay, so I'm getting the Adams on mute. On mute, let's talk.
Yes, sir.
Okay. Any knowledge on HTML,
Yes, sir.
CSS?
Not detailed.
Okay, CSS not detailed. Okay. So I put asterisk behind it. Okay, JavaScript.
Yes, sir.
Okay, you've done a bit of JavaScript. Okay, what IDE do you use? IDE. What IDE do you use? Do you know about IDE?
No, sir.
Okay, no idea. All right. Do you have any idea about frameworks?
No.
Okay, no idea. Okay, so framework. Give me a minute. Framework. Okay, so framework, no. I have at least two. So okay, all right. That is fair. So I know the. Okay, so all right, I'm getting some feedback here. Okay, good. Collins, on mute. Collins Obin Odro. Yes, this is what I'm talking about. He may have dropped the phone somewhere else. He's not behind his computer. Okay, great. Salom, on mute. Yes. Any idea? Any idea on HTML?
Not deep. Not deep.
Okay,
Started the surface, but not too deep.
Okay, so I have not too deep. Okay. What about CSS?
Same.
Okay, CSS same. JavaScript
Same.
same. Okay, very
Yeah.
well. Okay. Do you know what an IDE is?
Read about it, but not done anything with it.
Not done anything with it. Okay. All right. Okay, so you can mute now. Andrews.
Sir.
Yes. Okay. Great to have you. Any knowledge on HTML?
Yes, sir.
Okay. So there you go. CSS.
Yes.
Great. JavaScript.
Yes. But
Okay.
I use a React framework.
Okay. So you do React.
Yeah.
Okay. Okay, that's fine.
And I know a bit about Node.js. Mm.
Okay. You know a bit about Node.js. Okay, that's backend. Okay. All right. Okay, great. What IDE do you use?
IDU.
IDE.
I don't know much about IDE.
What do you use to code?
Visual Studio. Oh,
Yes, that's an IDE.
okay.
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 Okay. All right.
Hello?
Yes, I'll be back. I'll be back shortly. A minute, please.
Okay.
Sure. All right. So thank you very much. Yes. Um, who was speaking? Yes. Okay. So who just spoke? Who just spoke? Before I asked for a brief interruption. Who was speaking?
Same Andrews.
Power off.
Okay. Okay, that's fine. All right. Okay. So Sayram. Hello, can you hear me?
Yes,
Please.
please, I can.
Very well. Please okay. I want to find out any prior knowledge on HTML. Have you done anything on HTML before?
No, please.
Okay, so no. CSS?
No,
Okay, no. And JavaScript?
no.
Very well. Okay, so have you done anything on coding before? Have you tried to code something before?
Yes, please, but I tried with C++, just the
Okay,
foundation, the fundamentals.
just the fundamentals. Okay, that's fine. Okay, so I get your level now. All right, thank you very much. Emmanuel, if you can hear me on mute, please.
Yes, I can hear you.
Okay, very well. Any prior knowledge on HTML?
It's been a very long time, so fortunately I've forgotten all those.
Okay, and what about CSS?
Yes, I do. But it's
You
been
have
very long time.
a very long time. Okay, okay. And JavaScript?
That one done.
No. Okay, so at least all right. So have you done anything? Have you done any coding before? Have you tried anything before?
Yes.
Is it a self-taught?
No, but that was those days. It's been very long with C++.
Okay, okay, that's fine. Okay, okay. So generally, it appears that at least you attempted it, but it's been a while now. Okay, so it's understandable. Very well. Okay, that's fine. I see iPhone. Who is iPhone? Normally, when you log in, just put your name there so I know who I'm talking to, please. All right. So who is iPhone?
Probably it's me, Adams, but it seems I had a license, so now I log in on my phone and I'm using that one. That's why, please.
Oh, okay, that's fine. Great. Any prior knowledge on on HTML?
Hello, sir.
No, I didn't hear you. Any prior knowledge on HTML?
No.
Oh,
I've answered my own long and you indicated on that.
oh, okay.
Yes.
Okay, that's fine. All right.
Okay.
I think there's a balance. So with the information that you've given out now, there's a balance. Okay, so it means that we need to try and get everybody on board. Okay, so those that join later on, I was telling your colleagues that for this class, because it's a technical course, okay, I would suggest that if you can have two devices, okay, the device that you're going to work on, and then the device that you'll be taking the class session on. Okay, so you have two devices where you have the class session, and then of course, you are working on the other device. Okay, so unless in the extreme cases where, for instance, as you mentioned, you had power outs, your light out and all of that, that is understandable. So try as much as possible to have two devices so that we can work together. Okay, so we can work together because what I'll be doing is that I'll be asking you to share your screen. So what you are doing from your end, I may ask you to share it so that we all know what you're doing. Okay. All right. So that's how we are going to have the class going forward. All right. So let me just share something with you. Okay, so we want to go through what I refer to as client server. So after this, I'll share the slide with you. So we all agreed that Wednesday, Thursday, okay, Wednesday, Thursday, from 8 to 9 in the evening, PM, okay, 8 to 9, we will have additional class session, okay, to be able to do more. All right, so 8 to 9. So if you are working and you be unable to join, just let me know. Okay. All right. So we want to do class client server module. Client server module. I believe you have all heard you've all heard a lot of if not all of you, some may have heard client server module, of which I will explain in detail. Okay, so we need some of these things to be able to understand what we'll be doing. Okay, so what is a client? A client. So in web technologies, a client, okay, do well and take notes. A client is basically what we refer to as a service requester. Okay, so our browsers, the browser you use, Mozilla, Chrome, Safari, and all of that, those browsers are referred to as clients. Okay, so in web technology, a client is referred to as a service requester. So when you log into your email, your Gmail using your browser, your phone, okay, using the app on your phone, the app is a client, okay? So when you are able to log in into your bank account, you are using the client, okay? You are using the client to make a request. So if you want to check your account balance, for instance, a lot of banks these days, they have apps. Okay, so they will ask you to download their app and then check you can perform your banking transaction and all of that. Okay, so the app in itself, okay, we call it a client. So we use the client to make requests. And also we can use a desktop computer, okay, as a client. So these are all clients. So in an office, for instance, in an office, when you are able to share a printer, okay, let's assume that you are sitting behind a computer, a desktop computer in your office, and you are using that computer to be able to print through the company's printer. Okay, so it means that the printer is not close to you, it is not for you. But if you are able to use your computer to print from the company's printer, you have made a request. Are we good? So you have made a request. Okay. All right. So all the English that you're seeing here, that is the summary. Okay. So you can say a thick client, a thick client is one that offers rich functionality and carries out most of the data processing and all of that. So rich functionality, for instance, banking application is an example of a thick client. Okay. So you're basically doing everything via the clients. So for instance, those that are able to buy prepaid credits using the was it the ECG app and all of that, it's an example of a tech client, okay, because it's rich in functionality. You can buy prepaid credits, you can do a top up, you can virtually request a meter. Okay, so then the number of functionality, okay, within the space, all right, we refer to it as thick client. So that's English, thick. Okay, and then of course we have thin. All right, so it refers to a lightweight, okay, which depends on the resources of the host computer to a great extent. Okay, so that's basically the opposite of thick. Okay, so if I may ask, the example that I've given on the thick clients, okay, who can try an example on the thin clients? This one, the thin. I need an example. Can anyone try?
Hello.
Yes, I can hear you. This one.
Yeah, okay, so in my opinion, it's like one computer that has been with one system unit and everything that is set up, and it has been connected to several computers. So all those several computers depend on that one computer for services.
Okay, so give me a real world example. Give me example because I need you to understand it before we. So
Okay,
an example, yes.
so like let's say a school ICT lab where there is only one computer with a system unit and everything over there that has like some high specs, like some high spec machine. So normally the other computers are all networked together and they depend on that one machine at the lab. So if that machine goes off, maybe the rest of the machines would be able to get access. Sounds
Okay,
right.
not bad. Okay, so basically, that's what we refer to as a client, and then the hybrid. Okay, so the hybrid. Anytime you hear of hybrid, you know it's a combination of two things. Okay, anytime you hear of hybrid, then it means that it's just a combination of two. So in this instance, we say take clients and thin. Okay, so it has these characteristics. So anytime somebody asks you to develop a website, a web application, and all of that, okay, so you should have this at the back of your mind, okay, when you are developing. So what it means is that you should try as much as possible to know the clients that people will be using to access your website or your web application. Okay, so these days you don't have control over the device people use. I may be using a tablet. Somebody may be using iPhone. Somebody may be using Samsung a series. Somebody may be using a notebook, something. So you have no idea at all, okay, the clients that people will use to access a service. Okay, that is why as a developer, when you are developing, you need to um, put into consideration all of these, and then you can, code as such. Okay, so that is where, what's the name? Responsive design and all of these things come in. We'll get there. Okay, but that's quite a detailed stuff. All right, so we'll get there. Now, so we know what a client is. Now let's talk about what a server is. Okay, so let me give you a very simple understanding of what a server is. Okay, so let me give you a very simple understanding of what a server is. Now, when you go to, for instance, the restaurant, okay, and then you make a request. First of all, there's a menu. Okay, so you get the menu, you go through the menu, and then you make a request. Okay, so there you go. That's another I add on to the client. So you are the client. You have entered the restaurant. Okay, so in that setting, we say a customer, but it's basically the same thing. Okay, so you make a request. Oh, I want pizza. Now, the server, okay, is the waiter or the waitress. Now, he or she will take your request. Pay attention. He or she will take your request and then send that information to the kitchen. So the kitchen area or the kitchen itself is where they do the cooking itself. They do, so if you want a pizza and all of that, that's where they actually prepare your request. If it's rice that you want, that's where they prepare it. Okay, so the server would take your request and then send it to the kitchen. So having so once they are done preparing, and then they will give the what's the name, the response, which is the prepared food, back to you because you requested it. So that is how a server works. Okay, so let me give you, let me switch my window. Okay, so for instance, this is my server. Okay, no, this is my server, and then this is my request. All right, so the client is here. Okay, and then this is it. Okay, so when you look through this, okay, so let me drop. Okay, so that's my, okay, so this is my server, and then this is my client. There you go. Okay. So if I go online and punch https www. Let's say z technologies ztech.com. Or let me come back to let's say Stanbic. So this yeah, you'll be related to this one the more. Okay, so stanbic.com. Now this is the request. Okay, so once you launch your browser and then you type in this URL, we call it the request. So that request goes direct to the server. So this is the server. And then once the server, so this is my request. And then this is my response. You need to understand this because we will deal with it the more. Request and response, request, response, request, response. Okay. So this is my request. So if I punch this in the browser, I'm making a request to Stanbic. So this server, for instance, this server has a lot of information. Okay, so simply means that a server is a computer that stores information. Very simple. Okay, so let me put this thing up. Okay, so Stanbic. All right, so this is how it works. So once I punch in the request, all right, it sends the request via HTTP. Okay, we can add the S for now. So this is protocol. All right. So with a simple restaurant analogy I gave, immediately you get into the restaurant, okay, and then you make a request. The request that you make, it is somebody who will send the request to the kitchen, okay. So for instance, so let me just do side by side here. So the request will go to the kitchen here, and the person who will take the request to the kitchen is the protocol. Is what we refer to as the protocol. So in every URL, once you see HTTPS, we refer to as the protocol. Okay, it is that technology that will send the request to the server. Am I moving too fast?
No, please.
Okay, so it's clear. So this protocol will move the requests to the server. So normally what happens within the server is this. The request will be roaming. Okay, so it will just be going around. That is why when you are browsing, unless of course you have a very high speed internet, when you are browsing, sometimes you have to wait for the loading bar to finish loading. What is happening is that it is looking for the information for you. That's simple. That is why when you type in a URL, you have to wait. You have to wait. So up until now, they are trying to build some technology that would bring the response in a split second. So before you type, then you have your response. Okay. So that request, okay, it sends by what we refer to as the protocol, which is the HTTP. There are several protocols which we'll get into later. Okay, so that request goes roaming through the server, and then, oh, it sees it. So once it sees the information that you are looking for, okay, then that information, the server will process that information back, okay, back to the client, in this case, back to the browser. So that is why if you type in anything on Google, it gives a response. So you have a search results. Okay. But when in the event that you make a request and then it returns 404 or it returns server not found, what it means is that the request was sent via the HTTP, but the HTTP was unable to locate the information. Then it will send information back to you as server not found or information not found, or sometimes 404 error. Okay, so whenever you hear of client server, this is what it means. So you have the client here, in this case, our browser, and then you have the server. Are we good? Any question? Try as much as possible to ask questions because I don't repeat my class sessions. So if you are not clear, please let me know so that I can. It's a very what's the name? How do I even put it? Quite a lot of things we need to understand. So you need to grab this, and then we are going to build on this. Okay. So if you are not clear, I'll give you a minute. I'll give you a minute so you can.
Hello, sir.
Yes.
Please go back to the previous slide.
Okay. This.
No, the diagram, the one you just
Oh, the one okay.
to us.
Okay, yeah. Do you see now?
Yes, please.
Very well.
Please,
Go ahead.
kindly explain again from the response to the client, the browser.
Okay. So this is what I mean. So this is let me just change this. I was using the human being because I wanted you to get the understanding. So this is my browser. Normally the address bar is here. Okay. So if you punch in anything, so let's HTTPS. Okay, so Stanbic. That's an example I'm giving you. So yes. Okay, so normally this is what you do. Okay, so once you punch in the address here, the URL here, okay, this HTTP, okay, so all right, so this is the full meaning, hypertext transfer protocol. So it is a protocol, okay? So HTTP, once you punch in this and then you hit enter on your keyboard, it is the HTTP that sends the request. Don't forget that once you punch in the address in the address bar, it is a request that you have made. Okay, so then the HTTP grabs the request and then sends the request to the server. Okay, so this is an example of the server. And then once the server finished processing it, now when we talk about server processing, there's a lot that happens here. We'll get into it later. Okay, so for instance, if this is where the information is, okay, don't forget that information on the server is more of folder. You know, on your normal Windows machine, how do you organize your files? You organize your files in folders. Okay, so you have a folder where you keep your documents. You have folder where you keep your movies. You have folder where you keep your pictures. You have folder where you keep your MP3, your audio music. You have folder where you keep all those things. You don't mix them together. It is the same with a server. So a server organizes data in folders. Okay, so these boxes that you are seeing is an illustration of a folder. So once you type in the address, the HTTP carries their request, which is the address. So don't forget, anytime I mention request, you should understand what I mean. Because from time to time, now it will move from normal terminologies to web technologies. So I may forget myself and then be mentioning, oh no, okay, those technologies as and when we make progress. Okay, so but you need to understand. So anytime that you punch in this address, okay, it can be anything. Okay, it is a request. Now the HTTP carries it and then now sends it to the server. Okay, so the server will be looking, it will be that request, the HTTP will send the request and then the server will be performing that transaction, looking through it. And then once it finds the information you are looking for, it sends the information back, still through the HTTPS as the protocol back to the browser. So once it sends the information back to the browser, that's where you see a web page. Okay, so then you can see their logo, their menus, their banner, and all of those things. Okay, so what you are seeing here is a response. We call it a response. But if you don't see anything and what you see is 404, sometimes you browse and then you see something like this. It means that when you sent the request, okay, and then HTTP carried it, the HTTP went looking for the information. It didn't find the information, and that they have to send you an alert. They have to send you a response. Okay, and then that response is 404. Sometimes you have it displayed on your browser as server not found. What it means is that the server didn't find the request. It didn't find any information that you're requesting for. Okay, so primarily there are several reasons to it. Sometimes it may be wrong URL. Okay, so when it's a wrong URL, the server doesn't know it anywhere. So it won't even find it. It will go roam, and come back and then display 404. Tell you that I didn't find it. Sometimes instead of Stambek, you type maybe Stambek with a double C. Now there is no information on Stambek because it doesn't exist. Okay, so then whenever you see server not found or 404, what it means is that the response was not delivered or there is no response to your request. Sarah, are you clear now?
Yes, please.
Okay, so with this, I believe that all of you are clear and you understand this. Okay, so we are going to move on. Okay, so let's make progress. Let me see. Let me share the slide again. Okay. I think I need to share my entire screen so that I can. Sorry. Okay, so that's a server. Now we have different types of server, okay, which we will look into later on. But let me give you, let me take a picture. Okay, so for instance, let me open this on Google and see something. Okay. Can you see my screen? Now you can see that yes, this is an example of a server. So a server is not different from normal what's the name? Normal computer. What is happening here is that a server is rather configured, okay, to process requests. So computers are servers. Do you understand? So when your computer is not able to process requests, we don't call it a server. Okay. So you can see these are the specifications of a server. So look at it. I am yet to see, I don't know if any of you have seen one before. I am yet to see a computer, a normal PC that has a storage capacity of 8 terabytes. Have anyone seen one before?
No.
Yes. Okay. So it means that the server is a high, I see a chart. Okay, very well. It's the same thing. Okay, so a server, all right, is a normal computer, but with high specification. Okay, with high specification. Why? Because there are a lot of clients, okay, making requests at the same time. We are here, somebody is browsing. Even when we take Ghana, for instance, we are about 32 million. If I'm not mistaken, about more than almost half of the population at this moment as I speak, they are making requests online. They are browsing for news. They are looking at pictures. They are watching Netflix. They are watching movies and all of that. So there are a lot of requests going on at the same time. So that is why when you don't have a server of high capacity, you will crash it. You will break it down. Okay. So normally a server is stored in a very cold temperature. It's because of the requests. Because a lot of requests are going on. Even here, this Ghana, about 32 million. So if you strike the average, and then from 16 years, 15 years, they're able to go on Google and browse and play games and all of that. Okay, so from 16 years, when we strike the average, we are talking about almost 25, 26 million people making a request at the moment. This is only Ghana. So imagine Africa, imagine the world, imagine all that is going on. Okay, so a server is a computer with a very high specification that has been configured to process requests. That is all there is to a server. So I was showing, so this is an example of a server. So let me show you a server room, server rack. Okay, I think this one. Let me preview this one. And now look at it. So you can see this. I'm on Google. I just search a server on Google. So I want to illustrate something to you. Now, so you can see this is a server. This is a server. This is so whatever you are browsing is sitting somewhere in somebody's room with a very cold temperature. Okay. The reason being that without servers in a cold temperature, it will burn. It will catch fire. Okay. So you can see this is an example. Okay. So you can see where my mouse, my scrolling is happening here. So you can see. So you can see this is a server rack. Okay. Arranged in a very high, temperature and all of that. So you can see an example. Okay. So this is a server administrator. This is what they are doing. Okay. So you can see that maybe there's something going on. There's an error somewhere. He's trying to fix it up. Okay. So you can see, look at it. So if you are able to browse Instagram, if you're able to browse Facebook, if you're able to browse YouTube seamlessly, you are browsing from a server room like this. This is what is happening. Okay, so if you are able to on X, if you're able to send message, somebody sends message within a minute, the message has gone. Somebody retreats. Somebody, a lot of things are going on. It's all happening here. Okay, so for X or for Facebook, for instance, they have a server, okay, a server room that is closer to us. So for instance, in Ghana, the closest server for Facebook, okay, is in South Africa. Okay, so what is happening is that whatever you are doing, browsing on Facebook, looking at people's pictures, commenting and all of that, the proximity, okay, to that request is South Africa. So the request hits the node, the South African node, and then it will give you the response. So, okay, if the response is not found on the server in South Africa, it goes to the nearest location. So from here, it goes to what's the nearest location? Nearest location up north somewhere. Okay, so the people in Asia, they also have a server in Asia. So that it doesn't mean that we are all browsing the same server, the one in South Africa. No, the one in South Africa, for instance, is for Africa. So that is how they have deployed the service. Okay, so when you go to Asia, they have a server close to the Asia area, China, and all of those places. Australia, there's a server there. Okay, that is how Facebook has distributed their server. Okay, so let me browse Facebook data center, and then you see. Look at the data center. This is somewhere in is it Ohio? This is data center in Sweden. This is Sweden. And this is Ireland. Look at it. This is Ireland. So when you're able to browse Facebook that seamlessly, this is what is happening. They have a lot of infrastructure. Okay, a lot of infrastructure. So they are opening servers everywhere, powered by renewable energy, solar, and all of those things. Do you get it? Okay, so this is okay, a lot of them. Okay, so just one website, but look at the infrastructure that is powering all these websites that we are browsing. Okay, this is even for even Facebook, not to talk about YouTube, not to talk about X, not to talk about Netflix, not to talk about all those tech companies, Amazon, eBay. You're able to buy, you're able to sell, you're able to do all of these things. They are all happening on the server. So this is an example of a server room, okay, or which we refer to as data center. So it's basically the same thing. So it's a group of servers that have been put together in a rack. Okay, they have been put together, arranged nicely, and all of that to be able to serve your requests. Okay, so when you are seeing this, when you're able to browse things on your phone so easily. This is what is happening behind the scenes. All right, so let me go back to the slide. Okay, so now I've shown you what a server is. So when we talk about client-server model, I think I have explained it to the barest minimum so that everybody can understand it. So let's see what is happening here. So it says what? A client-server model refers to a distributed, okay, application framework. So that's a distributed I'm referring to, where you have servers spread across the entire universe and all of that. Okay. Yes. It says what? It divides tasks between servers and clients that are present in either the same system or interact over a computer network or in the internet. Okay. And there you go. All right. So this is just English. I'll send you the slide. Okay, so that you read. Now, whatever it is that I explain, I teach. Okay, you have to do more. You have to learn more. Okay, because normally my questions are a bit outside of this of the slide. Okay, so you have to do more outside of what I teach. Okay, but basically you have to understand what client-server model is. So we are talking about requests, we are talking about response, we are talking about servers, we are talking about protocol, and all of that. Okay, now we want to talk about categories. Okay, so this yes, is the same thing. Now there are categories. One-tier architecture. This is it. So one-tier architecture involves a program being run on a single computer. Okay, where there is no requirements regarding access to the network. Okay, so network protocols are managed by user requests, hence the code remains simple and no traffic. Okay, so for example of one-tier architecture, so don't forget client-server model is what we are dealing with. But there are types, there are types of client-server model. And the first one is one-tier. Okay, an example of a one-tier is now when you install Microsoft Word, okay, or maybe Microsoft Access on your computer, whatever is happening, whatever it is that you are doing, okay, is stored on the same computer. So for instance, if I'm doing anything on Excel, the Excel that I'm working on is an application installed on my computer. Are you following? It is installed on my computer. So I am able to do my Excel, I am able to do my PowerPoint, I'm able to do whatever I'm doing. Okay. So what it means is that is a one-tier. So this is my application, and I'm able to access its local database. Okay. So local database is just storage. It's just like you are working on Microsoft Word and you save your file. When you save your file, you can either save your file on desktop or your document, whatever it is. That file that you have saved is sitting on your laptop or your computer. So we call it one-tier architecture. We comprehend. It's called one-tier architecture. Get this straight and once and for all. Okay. So now, should anybody access my network, unless of course I have configured it, all right, they cannot access my file. Okay, so that is the one-tier architecture. Now let's come to the two-tier architecture. So two-tier architecture, what's the name? The slide says that it involves the server, client, as well as protocol by which two tiers are linked. So in the code or in the figure represented here, you can see that we have the data source, and then the client. Okay, so this is what I illustrated. So what I illustrated in the with my diagram is actually a two-tier that I did. Okay, so we have a data source, and then we have the client. Let me give you another example. Now, okay, so again, let me delete this. All right. So this is my laptop. This is Emmanuel's laptop. And then this is Desmond's laptop. Okay. Desmond is making a request. Emma is making a request. Prince is making a request. Okay. Now, this is my server. And this is my data source. So the data source, example of a data source, is a database. Okay, so I want to illustrate something again here. So this is two-tier, don't forget. Okay, so all these are requests. Okay, so this is my laptop. Okay, so laptop A, B, C, and then this is my server, and then this is the data source. So this is what is happening. Now I want to use NIA as an example to illustrate two-tier. NIA is National Identification Authority, producers of Ghana card. Okay, producers of Ghana card. Now, this is what they are doing. So wherever you go to, if you want a government service, they will ask for a Ghana card. From banks to government institutions to almost every place, they will ask for the Ghana card. Now, what is happening here is that this is my data source. Okay, this is my data source. Okay, so let me extend it here. So what you are seeing here, I'm only drawing it here, okay, so that it will be visible for you. Okay, this is the database of NIA. Okay. Okay, so what do you have here? You have name. You have DOB. I'm only trying to replicate what is on our Ghana card. Okay, so card number. That's my card number. And then okay, so date of issue. So let me keep it that simple. So let me give an example. Emmanuel. So Emma is here. DOB is, let's say, 20th March 2000. An example. And then my Ghana card number, Emma's Ghana card number is GH hyphen, okay, that's it. And then the date of issue, let's say 2025. So you see what is happening here. All the information here is the same thing. Okay, so we have Ima, the next person, we have Desmond, a whole lot of people. So this is the database of the entire Ghanaian population. Okay, so when you go to the bank, for instance, so this is Stanbic, and then you want to make a withdrawal. The teller is here. Okay, so the teller is asking you, sir, can I have your Ghana card? So he takes your Ghana card and then inserts the Ghana card. So let me copy this. So this is the Ghana card. Now you give him or her your Ghana card. He will make a request on the Ghana card. So sometimes they will ask you to sit down. Either they print the Ghana card or they want is the information on the Ghana card. Okay, so sometimes when the network is slow, they will ask you to wait a while. They will print the card. And then once they print the card, they are okay. So it means that they will punch in the Ghana card. And then that Ghana card number is sent by the HTTP. Okay, so that HTTP goes to the server. So don't forget the server, the database is sitting within the server. Okay, so the HTTP takes the request and goes into the server. So it's just an extension of that here. Now, because it's a lot of people, the request will search the Ghana card column. And then once it sees it, it pulls this information back as a response, okay, to the teller. So once the teller sees that you are in the system, once they see that you are in the system, then you'll be allowed to perform your transaction, either by withdrawing money, making updates, signing check, withdrawing check, depositing money, all because he or she has confirmed that your name is in the database of their server. Okay, so as Ima is here at Stanbic Bank, Desmond is somewhere at the driver's license DVLA offices. Somebody is somewhere at Ghana Immigration Service and all of that. Okay, so all these people are making a request at the same time. Okay, so it is not one-to-one, but it is more than one. That is what we refer to as the two-tier architecture. Two is more than one. Okay, two-tier architecture. So you have the database separate, and then you have the client separate. So once you identify a two-tier, you should be able to know what a two-tier architecture is. So this is an example of what I have just illustrated. Now, with the one tier and then two tier, I want somebody to explain a three tier for me. Somebody should try. So with a three tier, what is happening? I need a response. Somebody should try. Seiram.
Sir,
Please explain 3-tier for me. What is happening here? No idea, right?
Sir, please, I'm coming.
Okay, I'm waiting.
Okay, sir, please bear with my understanding from the explanation you gave.
Yes.
The 3-tier that
Do you want to hire a lawyer?
yes.
Anyone to rescue her? You have to speak, oh, because I've explained the 1-tier and then 2-tier. So who can help me with the 3-tier?
I want to have someone.
Emmanuel.
Yeah.
Okay, please try.
Okay, so what I have realized is that now there's the inclusion of interface where the
Yeah.
client interacts with this database through the interface.
Mm-hmm.
So the interface has made it a 3-tier. So that is how I understand it.
Okay. Um, yeah, close in a way, but okay. So who doesn't agree or who agrees? Do you agree to Emmanuel's explanation? Okay. You have to do more, all right? You have to do more. I give a lot of assignments, so today will be introductory. So Wednesday and Thursday we'll meet briefly, and then I'll give some work. All right. Okay. So client server database. Let me go back to my illustration again. Okay. Now, um, let me put the server here. And then let me take this out. Okay, so you now understand it. So let me move my illustration down here. Okay, this time I am going to use MTN Momo to explain it to you. Okay. Yes. Now, the Momo is an everyday activity that we perform. Okay. I'm sure yesterday some of you sent money to somebody and all of that. Okay, so I'll use that to explain the 3-tier. Now, this is I want to take my time and do it. Okay, so database. And then we have server or API. Okay. So let me move this one here a bit. Okay, now this is a Mumu vendor in my area. Now I go to her and say, oh, madam, I want to make a withdrawal. Then she will initiate the activity. She will initiate the withdrawal process from her phone. Okay, once she does that, I receive the notification to input my Momo PIN. So once she's able to do that, let me put her here. Okay. So she initiates the withdrawal requests through the server. And then I will receive, I am here. Okay, so I will receive, let me put the Emmanuel here. So that's Emmanuel. So Emmanuel is going to make withdrawal. So she will initiate the withdrawal. Okay, it will hit the server or the what we call API. So the API is application programming interface. Application programming interface. What does API do? The API also acts like the server, but normally they receive requests and sends a response. Okay. So the woman initiates the request to the API. And then the API will look into the database and see that the amount that I have, let's say I have 200, let's say Ima has 200 in his Momo account. Okay. So once you have 200 in your Momo account, you can't withdraw the exact amount, 200. Maybe you have to 190 or something like that. Okay. So you have in the database 200. Now, once you initiate the request, it goes to the API or the server, and then you will receive, okay, so it goes like this, initiates, checks the amount you have in your Momo wallet, which is the database, okay, and then sends the request this way. Okay, so sends the request back to you. So once it sends the request back to you, that's where you see a notification on your phone to input your Momo PIN. Okay, so once you input your Momo PIN, it goes again. The request goes again, hits the server or the API. Okay, goes back again to activate the withdrawal in the database. So now once it activates the withdrawal in the database, she will get an alert, you will get an alert. And then once you get an alert, and once you get an alert, she gets an alert, then she can give you the money that you are requesting for. So you can see that 1, 2, and the entire process here is 3. So whatever activity is happening here, so the request the request from the API or the server to the database, and then the database back to the server, and then to you is a 3-tier. Do you see it? Okay, so you have 1 person, you have 2, and then of course you have the system, which is the 3. So that is the 3-tier server client server model. Who doesn't understand this?
Hello, Sam.
Yes.
And please, the database is also in the server or it's separate from the server?
Good question. Normally, the database is within the server. Is a yes or no. And on the contrary, you can also have a database outside of the server. You know why? Because now let me try to how do I explain this? Okay. So you have the so there are instances where you have the what's the name? Let me put this one here so that I don't. Okay. So there are instances where you have the database sitting in the server. Okay. And then there are instances where you have the database outside of the server. So we have a data source. Okay. The reason being that when there's a cyber attack, okay, when there's a cyber attack on the server, it's easy for the hacker to grab the entire server. And what it means is that your Momo account is going to be compromised. Okay. But when the server, when the database is separated, before a hacker, so normally what a hacker do is that they track the break requests. That's what a hacker does, or they intercept requests. So once they intercept requests, so normally that's why the fraudsters, they will ask you to click some link, call some number and all of that. So they want to intercept the request. Okay, so once you separate it into presentation layer, data server, and data source, before the request would hit the what's the name, the database, there would have been some alerts. So that's where the cybersecurity people come in. Okay, so they will be able to track. Oh, there's a request, there's a harmful request that is coming in. Then they will block it. Okay, so that is where we have firewall and all of those things. We'll get there. Okay, so in these days, the best of architecture to use in a situation like this is a 3-tier. Okay, so you separate the data source. Don't forget, you can have the data provided your system is very secured. You can have your data within the server. It is accepted. Are you getting me? It is accepted. But the most appropriate way is to have your data outside of the server. Okay, sitting somewhere, and then the server API is doing its own thing. And then, so before the request comes in, it hits this place, before it to go through to fetch the data from the what's the name from the database. The system administrator will flag it and know that there's a bad or there's a harmful request that is coming in. Okay, so where you have data sitting in the server like this, immediately the hacker intercepts the request. It's easy for them to get into the server quickly. So they normally they do that within some few seconds they are done. Okay, because they need that information to be able to access, the resource. So once you separate it, you are basically securing your data or your information. Are you getting me? So in the case of the NIA, the example that I gave previously, the NIA is having the data, okay, but banks are accessing it. All government institutions are accessing one single database. Do you get it? So before there will be any attack on the data, because they've employed cybersecurity people to be able to monitor requests and all of that. So once they have the data coming, once they have requests coming in, they are seeing it. Okay. So when you go to the bank or you go to the Momo vendor, the Momo vendor will ask you to wait. It's the same thing. And then she will initiate the request. Once she initiates the request, and then there is no harmful interception, there is no hacking anywhere, then you will get a feedback to input your Momo PIN. So normally when the server is down, that is where she will tell you that, oh, since morning, the system has been down, the network has been down, so you can't make withdrawal. Okay, that is what happens. So the most appropriate way in this instance, when you are doing a high level transaction, normally financial transactions and all of those things, it is appropriate that you separate the layers. Okay, you separate the layers. You have your interface, you have the server, you have the API, and then you have the database itself. Are we good? So that is how it works. So this is a three-tier model. Any question? Okay. So no question. Now we move to N-tier. What is the N-tier saying? So no, don't forget we've done 1 tier, we've done 2, we've done 3. Okay. So what is the N-tier? It says an application divided into logical layers by N-tier architecture. What it's saying is that there is separate responsibilities as well as manages dependencies and physical tiers that are run on separate machines. Okay. So what I have done in 3-tier, okay, the explanation I gave in 3-tier is for the N-tier is just a multiplication. So in this case, the Momo vendor will be 1, bank transaction will be 2. You are sending money from your Momo to bank accounts is 3. Okay, so these are variations of 3-tier. Okay, these are variations of 3-tier. So when we say N-tier, that is what we mean. It is just an extension of 3-tier. Okay, so you can see that one, the layer, we have application layer, we have the web service, we have the database. Okay, so N-tier, I can say that, let me go back to my diagram. Okay, so with the N-tier, okay, with the N-tier, I can extend it. Okay, so I can extend this one to be another database. Okay, or to secure the system. Okay, so yes. So maybe this one, in the case of NIE, this one can be no, this one can be card number database. Okay, so this database only houses the Ghana card number. So like this. So this is our number. So for instance, if this is my Ghana card number. Okay, so I have a separate database, okay, for just the Ghana card number. And then this one can have name, date of birth, and issuance, date of issuance. Okay, so date of issuance and expiry dates. Okay. All right. So that is this. So for what I've done here is N tier. I have just extended the 3 tier. Do you understand? I have just extended, so I can further extend it all to secure my system. That's what I'm doing. Okay. So in a client server model, you can separate, you can extend it as much as you can. Okay, that is to be able to protect your system and make it scalable. Scalable, I mean that you can maintain it, you can improve it, you can make it big. Okay, that is scalable. So imagine that I have all this data sitting here, just here, and then there's a problem. I will lose it. I will lose the data. Okay, if there's a problem, I will lose the data. So for instance, I don't know if you remember when the hospitals were signed on to a particular system, that all hospitals in Ghana are on that system. So you go to hospital A, your data is there. You go to, let's say, Smith Hospital, you complain of headache, whatever it is that you complain of. And then you go to Kolebu. That data is still sitting there. Okay, so that is an example of a 3 tier. So every doctor can access, that data. So the doctor in this case is a client making a request. You understand? So 3 tier is just an extension. Sorry, N tier is just an extension of a 3 tier. Okay. All right. So I think yes. So this one is just English language. Okay. So you need to understand. If you don't understand, I'm sure. I think what's the name? Better. The faculty officer. I think they sent an email that they are going to record and share it to the student after class. I don't know if it will still work, but that's the idea. Okay, so you are sending. I'll send you this slide anyway. So that's the first topic that we have dealt with. So we need to clear some of these things out of the way, and then before we get our hands dirty. Okay, so let's see some of the benefits. It says a client server has many advantages, which I mentioned below. Okay, facilitates protection of data. Yes, that's what I mentioned. Okay, and then manages easily user authorization and authentication, addition of resources, servers, network segments, computers to a client, and all of that. So this is just pure English language. Okay, so when I drop the call, I'll share the content with you. Okay, so any question?
Sir,
Yes, Aaron.
please, does it mean that the server doesn't store any information at all?
Okay. Let me go back to the diagram. Okay, so within the server, all right, I don't know if I showed you the server specification on the I think, do you see the screen now?
Yes.
Okay, so you see this server. This server contains, it's just like a normal computer. It has a memory, it has memory, it has hard disks, it has a network cable, it has all the features of a normal computer. This is a desktop computer. Okay. But within the storage, within it has 8 TB of storage. Okay. So your computer, the personal computer that you are using, it has storage. So where you store your files is on a storage device. Sarah, do you get it? So
Yes.
your computer can be damaged, but you can still recover your files via the storage device, right or wrong?
Right.
Absolutely. So the server is just housing components. So it's a computer. So the server, have that in your mind. The server is just a computer, just like your computer, but it has been configured, okay, in a way to process requests. That is all. And the configuration is done by some softwares that you need to install and then do blah 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 before the computer becomes a server. Do you understand? So on this picture, it says it has 8 storage hard drive. Okay, so meaning that I can store data, okay, to the capacity of 8 TB. Now, 8 TB is huge because normally even text file is in kilobytes. Normally text files, they are in kilobytes. They are not that huge. Okay, so for you to be able to have 8 TB of storage, that's quite a huge server. But as compared to YouTube servers or storage devices, they are different because video file is heavy. Do you understand? Video file is heavy. So if you want to run what's the name? A multimedia system, you will need a higher storage. Okay. So the server itself doesn't store information. It is the component, what we call the hard drive, that is what stores information. So in the diagram that I showed you, you can see that this is my server. Okay. So within the server, you can have, okay, so within the server, this is where my hard drive is. So it is the hard drive that is storing the information. Okay. So I can lose this, what's the name? This server. Okay. That's why I mentioned to Emmanuel that once you have the data within within this and somebody steals this whole server, you are done. Okay, but once you separate it, okay, once you separate it, so this is the storage, this is the storage. Once you separate it, and the person breaks into your room or your server room and steals this server, okay, but because this one is in another location, you are safe. So you only have to get a new server, and then of course do the connections again. The connections are done with the cables. Okay, sometimes wireless connection and all of that. You understand? So the server actually doesn't store. It is the hard drive component within the server that stores the data. Sarah, are you okay now?
Yes.
Very
Thank
well.
you.
You're welcome. So any other question? Yes, I feel to remind you that I take attendance. Okay, so I'll take the attendance for this class. Attendance is part of the score. Okay, so it's all calculated as part of the class score with assignment and all of that. Okay, so I'll take um the attendance and then yeah, I think by the time we have another class. So let me just quickly take the attendance. I'll share the attendance with you on our platform. Okay. All right, so let me see. Yes, I can see Sarah. I can see Sarah. I can see Emmanuel. Emmanuel Hatcher. Hatcher. Sorry. Desmond Tete. Mr. Saki. Okay, let me see which other names I have. Okay. Collins Obin Odro. Okay, I have Adams. I have,
I've changed my name. It's Alex Kwesisaki.
okay. Alex PC Saki. Okay. A J Kojo. Adrian. Okay, I have George. I have Stephen. I have Stephen Asamoah. Okay, who else do I have? Nyako Andrews. Okay, Noble. I hope I will see those names in my class list. Okay. Yes. Give me a minute. Okay, so 14 of you. I want to see if I can screenshot. Um, okay, so who hasn't heard the name? Maybe my view is not. If you didn't hear your name, please mention it. Let me put it up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I have 12 people. So if you didn't mention, but if I didn't mention your name, please mention it for me. Yes. Okay. So it means that I mentioned everyone's name. Yes, because I have 14. Yeah, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so we'll communicate on the platform. I'll meet you on Wednesday next week, 8 to 9 p.m. All right, so thank you and okay. So thank you. See you. Bye-bye.
Bye.